Okay, so the next section we're going to talk about are data sources, and what type of data sources we're going to talk about.
Well, we actually split this into two types of data sources. We have what we call traditional data sources. These are ones that have been around for a number of years. And then we have data sets that have been derived from the web crawling and the internet scanning that RiskIQ does. Okay. And those are what we call the crawling data sets, or you could just consider them more advanced data sets.
Okay.
So as we're introducing these traditional data sets, one of the things that we're going to do is explore what they look like inside of community.riskiq.com. So if you haven't already, make sure that you have an account and log in. What you'll be presented with is something that looks very similar to this screen, but maybe not exact. Before we actually run a query, I actually want to go through and quickly explore the account settings tab here up in the top right. And the reason for that is when you register for a new account, one of the things that we do is we, by default, stop any query from going to an external source, unless it's a RiskIQ source. And so you'll notice here on the sources down below, that some of them are checked. When you check those sources, it's going to produce different data sets. And so as we're running queries inside of our platform, keep in mind that it may look a little bit different for you, but that there's no bugs or issues, that in fact you're seeing the correct data sets. If you want to go and change this yourself, you can go into the account settings again at the top right by clicking the person icon and clicking account settings. So what we're going to do for the data sets that we're walking through is actually explore passivetotal.org. And you can run that search directly from the search bar here. And I'm actually just going to go and use our history. So clicking passivetotal.org, what this is going to do is it's going to load up the interface itself. And we have our query at the top. We have some history here associated with it. And then directly below our query, we have a bit of metadata describing the first scene, last scene, some of the registration information, and then the option to categorize this infrastructure. And when we say categorize, we mean a couple of different things. One, has this website ever been compromised that we've observed? Does it appear to be a dynamic DNS provider? And two, from a classification perspective, is this a malicious, suspicious, non-malicious, or unknown website?
Well, when you categorize, is that going to be just for me to see, or my team, or for the entire world to see?
That's an excellent point, especially knowing that analysts don't necessarily like to leak out information. Any action you do, from a classification to applying custom tags within the platform, is strictly tied to your account. It will not be shared with anyone else. However, if you do have an enterprise account, it'll be shared with your team there. So it might be something you want to consider. Okay. We like to leverage the classification simply because by classifying something, you'll actually derive a tag from it. So in this case, I'm going to submit the fact that this infrastructure is non-malicious. And when I go back and explore this in the future, by refreshing the screen, what we're going to see here is a non-malicious tag that's been added to the infrastructure, as we can see here. Now, what's nice about this is that when I pivot around the system and I see passivetotal.org in the future, I'm going to be seeing a color code that applies, that corresponds to the classification that I set.
So anything associated with passivetotal.org now will have that classification in the results?
Yes, anything that has that exact domain match. And what's nice about this is that as you're doing your investigation, you're pivoting around inside the system, it becomes incredibly valuable to have the classifications and the tag information, simply because it's a good way to figure out whether or not you've already looked at the infrastructure, or to give you some additional metadata you may not have seen otherwise. So directly below this bar here, we have a couple different visuals. The first visual is our heat map, and that's showing a 6-month window of resolution history that corresponds to particular days.
So when I see a bunch of numbers, what do the numbers represent?
So the numbers actually represent the unique number of resolutions that occurred on that particular day. Mm-hmm. So if we take the example here of May 1st, 2018, if I hover over that particular day, I see that there's 2 unique IP addresses that passivetotal.org is resolving to.
So there's also shapes in here as well. So what are the shapes? And there's a legend that's in the upper right-hand corner. So what are blue represents?
So the blue is going to represent routable addresses. We spoke before about cases where a malicious actor may choose to park their domain on a non-routable infrastructure. So you'll see some color coding in that regard, depending on the query that you're running. And in regards to the shapes, the rounded and the rounded caps essentially represent the first and last month of a particular month. So in this case, it's May 1st, so it's the start of May. We have a nice little round, representation here showing that it's the start of the month.
So sometimes when an attack happens, it's over a particular window of time. Is there a way for me to focus my results to just show me during that time?
Yeah, so there's two ways to do that. First, you can actually click on a particular day inside of the heat map. And what this is going to do is it's going to constrain all of the data sets below to just that particular day. However, if I wanted to, I could shift click to a larger period of time within that 6-month window and again, filter all the results below. For me, I want to actually just go through and unselect this in general and have this go back to normal. And one of the other ways that we can filter out this data is using the time bar below. So we have a 6-month history that's the last 6 months, and the time bar represents all of the information that we've seen. And this can become incredibly valuable just if you're looking for a particular time slice. Maybe you're looking at a piece of infrastructure that is associated with log entries that is a year ago. What you can do in the time bar is actually hover over it, click this, and what it's going to do is it's going to actually re-render that 6-month window above to just the data that matches during that period. And additionally, what it will do is it'll filter down the data in the table below to just the relevant material up to that period.
Yeah, I see that there's some new information that showed up, that it's the little triangle, so it shows that that was a new IP address on that day.
Yeah, that's exactly right. So again, following the legend here, just in case you forget, that little orange flag on the particular days is the first time that we saw a piece of infrastructure that was new. And what's nice about that is if I hover over that particular day, I can actually see that first seen value. In this case, it was a new IP address that we hadn't seen previously. That can be incredibly valuable for when you're doing an investigation. And then, of course, directly below all of this information is all these different data tabs that we have available with the rich internet data that we'll be discussing further. So we're going to start by covering the traditional data sets that we have available. And these include passive DNS, whois, subdomains, DNS, and hashes within the system. We'll cover some of the projects in open source intelligence as well. And what we're going to be doing here is actually just using passivetotal.org as our example use case as we walk through these particular data sets. So by default, when you run a query inside of community.riskiq.com, we're actually going to select the resolutions tab. Now what that is that's actually our passive DNS A record information. Now passive DNS is essentially a repository of historical IP to domain lookups. And if we have to go a little bit into the technical details here to understand this data set, but DNS, domain name system, is essentially a protocol that helps handle resolution. You can almost think of it like the phone book for the internet.
Okay.
And so I can have a domain that is easy for me to remember, but in order for me to route anything online, it has to be translated to an IP address that then helps route it through the rest of the internet.
It's like when you tell Siri, call Joe, and it knows to call Joe. And if his number changes, you just update it and it will do it.
That's exactly right. So passivetotal.org has IP addresses that it's pointing to. Now, DNS in and of itself, the protocol is ephemeral. Mm-hmm. So going back to our signals discussion, unless somebody's listening, that signal is not captured. And so what passive DNS does is it's actually a sensor that may live on the network or upstream, depending on your DNS provider situation, and it's recording any one of these DNS lookups. So in this particular case, if I were to type in community.riskiq.com, that's going to be associated with an IP address. And that IP address is then going to be captured. So we're going to have passive total community.riskiq.com associated with a particular IP address at a certain date and time.
Okay.
And with passive DNS, what we're doing here is we're building this historical repository that may be well over 10 years of information. And what's great about this is that the data source itself is able to show us these associations that take place that would otherwise be lost. Now, DNS has a number of different records. I mentioned that we in the resolutions tab are showing the A records. The A records in this case are really just the relationship between a domain and an IP address. Mm-hmm. We'll cover some of the other DNS types as well once we go through the DNS tab. But for all intents and purposes, what we're staring at on the resolutions tab is passive DNS information for A records.
So what are some of the other signals that we can glean from just seeing what IP address responded on this domain on a particular day? Is what other information is RiskIQ putting together to give me more background instead of just the nuts and bolts, the number to the IP address to the domain?
Yeah, so that's a great question there, because passive DNS by itself, just giving you a domain and an IP address association with the time, is certainly valuable from an analyst perspective. But you'll notice on our resolutions tab.
So if we go down to the very bottom of the resolutions tab, that's what we're looking at right now.
Yeah, and so what we're seeing here is that there's a number of IP addresses, and we've actually gone through and added some more information. So we've added geolocation information, we've added the network it was associated with, the autonomous system, and then the sources of which we got that passive DNS
So
data.
we're enriching the information that we got from the traditional data set to make it a little more useful.
Yeah. So if I were just staring at an IP address, it wouldn't be really clear to me that that they were definitely part of a different network. And so at the bottom here, looking at the first IP address that ever resolved for passivetotal.org, we can see that it was on a DigitalOcean service provider, and that that was back in 2014. And then if we begin to scroll up a bit, we see some of the IP addresses that got introduced in 2015 are actually associated with Amazon. And what's interesting to note there is that we're able to kind of take a look at this data set, and we're able to see there's a number of IP addresses, yet the service itself has always been in the United States. And that from a provider perspective, that Passive Total has only been on really two providers, DigitalOcean and Amazon. And that it was on DigitalOcean and then it went to Amazon completely. And so we're starting to tell a story here, and what's really interesting is having the guilty knowledge. PassiveTotal.org, when we founded the company, was using DigitalOcean, naturally. And when we got acquired by RiskIQ, there was a point in time where we were transitioning our infrastructure to Amazon.
Okay.
And so there was an overlap between those periods of time where we were on DigitalOcean and Amazon to maintain business continuity. And then eventually we went to just Amazon, which is what RiskIQ uses for their infrastructure.
So it's a nice way of looking at the history of that domain and see how it's changed over time and how quickly it's changed over time.
Yeah, we can see here, if we scroll back up to the top and we're looking at the visuals, these become immensely valuable from an analyst perspective because, one, I'm seeing in the heat map that we have data for passivetotal.org. And that's just denoted by the color. If there was no resolution history here, it would be blank.
And you were seeing no gaps. So it's not just been up for a few days and then down for a few days and back up. So it's been consistent for the whole time period that we have data for.
Yeah, and what's also helpful here is as a quick visual indicator, if we look at the time bar, we can actually see very quickly that we've had at least somewhere around 3 years of history or something close to that. And so this becomes really helpful as an analyst when I'm starting to ask questions like, how long has this domain been around? How often is it changing service providers? How often is it changing country locations? What is the frequency in which it's just changing IPs in general? How often are new IP addresses popping up on this particular host? And so those are the questions that you want to start asking yourself, really looking at the data in order to identify any patterns that may exist.
Now, will we identify if an IP address is in a sinkhole or something like that? Or
yeah, so unfortunately, there's not a single registry for monitoring sinkholes and detecting them, but RiskIQ actually does keep its own repository of sinkhole information, and when available, that information will be present within a tag associated with the infrastructure here on the right-hand side under the tags column.
Wonderful.
Okay, so we've looked at resolutions, which was the A records, and now what we want to do is actually explore the DNS tab, which is every other DNS type record that I mentioned before that's collected off of our sensors, either through the passive side of it, having a sensor on the network, or through active resolution by actually going out and manually going and getting this information.
So there'd be like the name servers, the mail exchange records, things like that.
Yeah, so it would be name servers, mail exchange, start of authority, text records, and C names or canonical names. All of those records will end up in this DNS tab. And what's incredibly valuable here is that much like the history that we have for the A records, we can see the IP addresses over time. With the we have all the history for all of the different DNS records as well. And from an analyst perspective, what I particularly find interesting and what I look for when viewing this tab is the length of history for one. How long has the infrastructure been around? And then with some of these record types, we can begin to infer the technologies that may be running parts of passivetotal.org. So for instance, we have a number of MX records that are showing references to google.com. Now, if you've ever set up Google for Business, you'll recognize these MX records because essentially what we're telling the systems through DNS is that all of our mail, like the mail exchange, should be routing through google.com.
Right.
And so now, if I'm thinking about this from an analyst perspective, I can then say, well, maybe passivetotal.org is actually the domain that's being used for email for maybe the company or the individuals associated with that. And in this particular case, that would be correct. We used Google Apps for Business.
Now sometimes threat actors might have specific IP ranges associated with infrastructure or name servers. So they might have that available. So by looking at this information, you might see overlap, or you might not see overlap in different infrastructure.
Yeah, I think it's a good point. You mentioned name servers. So in some cases, attackers will actually stand up their own name server, maybe even on the domain or one of their malicious domains. Mm-hmm. And so what you want to look for when looking at something like the name server records is the uniqueness that's associated with them. Because these become another pivot point as well. We could say, show me any records that also share the same name server. If it's a highly unique name server, then we potentially have all of the attacker's infrastructure. Now, in the case of passivetotal.org, we're actually using AWS DNS, and specifically Route 53, which is an Amazon service. Mm-hmm. So again, like thinking about, if I'm looking at passivetotal.org and I'm not necessarily certain if it's good or bad, one of the indicators as an analyst that some of the services are telling me is that passivetotal.org appears to be using Amazon for their name servers, okay? That it seems like they might have Google Mail set up, and looking at, let's say, these text records here, that we've gone through and configured SPF on our setup as well. So we went and validated who can send mail from our particular servers, or how we're going to accept that. Mm-hmm. And so if I'm thinking from an analyst perspective, it seems like there's a lot of work that's been put into this infrastructure. It's been around a while. It's got mail configured. It's got a third-party, cloud provider for its services that match the current hosting provider. Mm-hmm. And they've went through and actually set up some manual text records that help validate the authenticity of the domain. So something to keep in mind here is that with these DNS records, that helps us figure out how legitimate the domain might be. Having that extended history, having those services configured is probably not something that an attacker's going to do.
And the first and last scene to see if the infrastructure, is it brand new or is it something that's been around for a while?
Yeah, that's exactly correct as well. So looking at just the history overall, many of these records have been around for at least a year or more. And that's important to note here. And again, going back to our example for the resolutions tab, how we started with DigitalOcean and then transitioned to Amazon, you can actually see here individual points in time where DigitalOcean was used as our name server, and then we went up and then eventually swapped over to those Amazon accounts as well. And so again, much like passive DNS, one of the big primary factors here, you want to look at time. How long has the infrastructure been around? You want to look at, see if you can derive any services that are running, any technologies, and really identify how much work's been put in the infrastructure and setting it up. Mm-hmm. That might help you figure out what you're looking at is either malicious or non-malicious. Okay, so the next data set that we're going to be analyzing is subdomains. And, subdomains are pretty simple, but often I think overlooked by analysts, especially ones who are a bit more seasoned because they don't think to explore all of these routes. But for a subdomain, all we're saying here is that passivetotal.org is our root domain, maybe our primary domain, and the sub is anything that extends beyond that. So looking at the tab of results here, we have some examples where api.passivetotal.org or www.passivetotal.org. That API or www is the subdomain that we're looking at. Now, what's particularly interesting about subdomains is that they really give you an understanding of all of the different observations that have taken place. So, for example, looking at the tab here, there's a number of different subdomains that reveal a bit about the infrastructure. There's things associated with beta, associated with app, name servers that we've set up, or potentially nodes. And so the subdomains themselves are leaking out pieces of information that, as a defender or an attacker, I might be able to use to my advantage to figure out how built up this infrastructure is.
And when you're investigating a threat, it might be on a shared infrastructure domain, and that subdomain might have matched your own company, where the attack was targeting you, but with your company name on some other domain.
Yeah, believe it or not, some attackers will actually go and put the company in which they're targeting directly in the subdomain as a way to keep themselves organized. And in doing so, they actually reveal who they're going after and oftentimes the targets. Now, we're not always as lucky for that, but it is an avenue worth exploring. It's also worth exploring in cases, too, where the subdomains are highly unique, because those subdomains might reveal, a common theme, or, if a good example that I like to pick is login.paypal.com.evil.com. Subdomains are not restricted to just one level. They could keep on going all the way through. And so, as analysts, the most important thing for us to take away from the subdomains tab is that for every number of subdomains we have, there's a potential new piece of infrastructure that it's resolving to. So passivetotal.org may resolve to an Amazon Web Services address because that's where we're hosted, but app.passivetotal.org
Might go someplace else.
may resolve to something completely different. And so what's important to note here is that every single subdomain that we view is another avenue for exploration. And we can bring together that resolutions tab, the passive DNS information, to find even more.
It's those signals that are leaking out that link infrastructure together.
Yeah, and so what we want to pay attention to is just the uniqueness of the subdomains, the count of how many subdomains exist, and then whether or not we're observing any dictionary-based words or words that might be commonly associated with authentication services or webmail or other file systems, where an attacker may be trying to emulate a particular website. Seeing webmail.evil.com. And they may even go as far as actually putting a webmail interface up on that server to just make it appear more legitimate. But subdomains, like I said, often I think overlooked by seasoned analysts, but anytime you see them, you really want to go out and explore every single one, just because it could lead to new infrastructure where that one piece, at one time that subdomain was set up, the attackers made an overlap to some old historic information, and you're able to associate it back to them. Okay, so now we're going to explore the Who Is data set that's available to us inside of the Community Edition. Who Is essentially, it's almost similar to that phone book example that I used previously, where if you think of the DNS system as the domains kind of are the people you're looking up, and the IP addresses are kind of like the phone number, the Who Is service is kind of like, tells you a bit more about the person who registered the domain. And so Who Is, depending on the registrar that you're going through, the way in which they request information from you may be different. But for the most part, registrars are going to require an email, a name, an organization, a phone number, and some location information about you yourself, the person who's registering the domain. Depending on the registrar and the restrictions that they have set up, you may have to put in legitimate information where you actually have to send a copy of your identification to the registrar to validate who you are. But more often than not, you can put in any information you want. And so Who Is typically is valuable for understanding maybe who registered the domain, but keep in mind that it may not always be accurate. Now, the two things to keep in mind here, that even when the data is not necessarily accurate or even complete, is that the email address and the phone number associated with the record typically have to be legitimate. And I mean legitimate in the sense that they have to be reachable. The registrar has to be able to send an email to you, or they need to be able to call you up through a phone number and validate who you are and that you have a presence. Now, how we use this to our advantage from an analyst perspective is that we can look at the Who Is record. In this case, we're looking at passivetotal.org's record, and we can see here that we can actually identify the information. And so we have a unique email address, We have the name of our CEO for the company. We have our organization specified in the record itself. So this is not
private. This is not private information. This is not what they call privacy protected.
No, this is completely public. Anybody can see it. And in fact, that is our phone number for the business. Mm-hmm. But you do raise an interesting point. There is the concept of privacy protection.
Yeah, and in the past, it was privacy protected when it first started.
Yeah, so much like all the other data sets that RiskIQ has, we retain a history. And so what we were just viewing was the current record, where today that is publicly available. Anybody can see that. But what you just clicked on was the first record when we first brought passivetotal.org online back in 2014. And what we can see here is that the information that was previously attributable to us in the organization has now been masked off. And it's associated with a private registration, in this case 1-in-1, which was our registrar at the time. And so from a who is perspective, you kind of have a balance here. Sometimes there's going to be privacy protection, sometimes there's not.
And sometimes the threat actor might have not had privacy protection when he first purchased the domain, but later on added it on.
Yeah.
So it's a way to go back and look to see were there any records that were associated with non-privacy protected results that now I can pivot off of and search and find signals.
Yeah, so it's funny. It's because we're kind of the opposite case where we've privacy protected and then we opened it up to the web so people could see that RiskIQ was a legitimate resource behind this website. Now, from an analyst perspective, what I'm interested in is now understanding, well, can I make connections using this information? So I mentioned before that the information could be legitimate, like our Who Is record, but it could also be illegitimate. In other words, it's been faked. As long as the record contents are unique, then that has the potential to give us connections. So if I go and I run a pivot, maybe on domains@riskiq.com, which is the email address that we've provided.
I'm going to do that now. I'm just going to click on it. So
okay.
It runs the query.
Yeah, so what we can see here is that these are the other domains that have been registered with domains@riskiq.com. And you'll notice here that some of them don't even have the presence of RiskIQ in the domain name of themselves or one of the product names.
But we see our tag that we created earlier.
Yeah, so we can see our tag there that's showing non-malicious, but what we're also seeing here is it's other infrastructure that seemingly does not appear to be related to RiskIQ, but in reality, using the Who Is data set, we can see that RiskIQ actually registered it. Now, what's nice about this is that the Who Is system, being the sort of phone book that it is that tells you information about the actual record itself, gives us a couple key indicators from an analyst perspective. Mainly, how old is the domain? And we can see here that we have a current record from April that's listing the website itself. But we can go back through the history, and the Who Is records essentially gives us the how long the domain's been around. And I think you mentioned this before, but a domain that's been around for an hour is probably more suspect than a domain that's been around for 10 years.
Yeah.
And so when we're looking at a Who Is record from an analyst view, the questions we might want to ask are, how unique is the email address, the name, the organization, the phone number, and any other details? Does it appear accurate or does it appear spoofed? Even when it's spoofed, does it appear unique enough that it's not going to be frequently occurring? An example of that might be we had some malicious actors that use Marvel characters. You know, Tony Stark, when they were registering their malicious infrastructure, and you would think there's probably many Tony Starks registering domains when in fact there wasn't. And if you were to pivot on that name that they used in the email address, you would find all of the malicious infrastructure that these guys had set up. And so even though they didn't put in real information, we were able to leverage that to our advantage by making the connection.
They were consistent.
Yeah. Now, the other thing that you want to see here, and you want to take note of, we mentioned this on the DNS tab, but again, seeing the name servers that are associated with this Who Is record. Again, the DNS tab itself is going to have typically the most recent records, but there's times when the Who Is name servers may differ. They may change over a period of time. So you want to make sure that if you're looking at the Who Is record, that you're paying attention to the name servers and identifying if they appear to be highly unique as well.
Now, are you pivoting off of those to get the hosts that are associated with those to see if there's any infrastructure that's being shared between those name servers?
Yeah, like that would be something that I would consider doing. In this particular case, being that they're on AWS, there's probably a significant amount of overlap that's not related to us. However, if you look at the subdomain, which we just spoke about, you can see that the subdomain itself appears to have some sort of unique pattern. And so maybe Amazon is actually setting up that they have a core set of primary domains for Route 53 and their DNS service, and then they're including a subdomain that might be tied to each particular customer. So in fact, if we did pivot on those, we might find some additional infrastructure that we didn't know existed. What I do want to recommend here in general is that when exploring Whois records, it's easy to skip over pieces of information or ignore certain parts of it. For example, the phone numbers. In this particular case, we have one phone number, but as you're exploring the platform and looking at other infrastructure, you might identify cases where there's 3 phone numbers associated with the Whois record for each of the different sections, the registrant, the administrator, and the technical contact. I strongly encourage that you always explore all of those all of those different indicators, just because 2 phone numbers may reveal nothing, but that last phone number might be the reason for the overlap or the breakthrough in your investigation.
To link to other infrastructure that might be a known bad or something.
Yeah. And I think what's important, the last thing I'll point out with this data set is that we see it evolving. There's been some upcoming regulations that are protecting privacy, and there are obscuring pieces of this data set. And it's unclear how that'll change over time, but we do know that it's likely information that we're finding today in Whois may change and may not necessarily be available. So until that goes away, that'll continue to be available inside of community.riskiq.com, and we'll be able to continue to make connections. But there is the possibility that we could lose this data set going forward. Okay, so up to this point, we've introduced a couple different data sets that's available in community.riskiq.com, and we've sort of shown what those data sets look like, how they manifest themselves inside the platform, and maybe some of the questions that you might want to ask as you're looking at it. And so if we think back to the methodology and the infrastructure chains, how does that map, how do these data sets that we just introduced map into that world? Well, if we're looking at something like passive DNS, where we have the IP and domain relationships, we might have a starting point where it's an IP address. And then for using passive DNS, we could say, show me every domain that's ever resolved to that IP address. And that's going to get us 3 domains. And then we can run a further passive DNS query to say, show me all the IP addresses associated with those domains through history. And so essentially what we're building here is the friends of friends query. Starting with one IP, turning that into 3 different domains, turning that into 2 more IPs, and building out that chain.
So it's the signals linking the infrastructure together to show the relationships, so then you can see how those things interact and are related to each other.
Exactly. And then on the Whois side, looking at ownership of domain and how we can leverage that data set to form connections as well. We looked at passivetotal.org as our domain, and then we had that Whois email address that appeared to be unique, domains@riskiq.com. We ran a pivot on that, and we were able to discover a number of other domains that seemingly did not appear to be related to RiskIQ on the surface. But looking at the Whois records, we can identify the match between them.
And you had mentioned that even the telephone number might be associated with different email addresses completely, but those domains might all use that same telephone number.
Exactly.
And you can link them together.
Yeah, so this is just kind of building again on the concept of infrastructure chaining here and showing a visual up to this point in the data sets we've looked at.
Now we want to talk about hashes, but we don't have any hashes associated with our domain, so let's pick one. So
okay.
arpanet-network.com.
Yeah, we know that this particular website has hashes associated with it. And so what we're seeing here on the hashes tab, essentially hashes are they're cryptographically secure ways of representing the uniqueness of a file. So commonly referred to as just malware on the network. You'll see different types of hashes, from MD5 sums to SHA-1s to SHA-256s, used to describe files. And essentially what's happening here is the hash is essentially a unique signature that describes the uniqueness of a file. So if the file changes, the hash changes. And what's nice about hashes is that it's a common way to refer to files that have been observed, either good or bad, and they're commonly used inside of the analyst community as a means to identify potential malware that's associated with infrastructure.
To say the same malware that was here is also here because it has the same hash. You're linking that together.
Correct. And it's just an easier way to refer to the file itself, because files can be large, they can be very complex, they also introduce the risk of infecting the network. And so by using a hash, it's a way to commonly refer to a particular piece of malware that we might be viewing. Now, in community.riskiq.com, the hashes tab is put together by all the partner relationships that we have. RiskIQ itself does not really collecting hash information. We're using our partners in order to get that. So one of the things that's interesting with the hashes tab is that just because you see results associated inside of the tab itself, it doesn't necessarily mean that what you're dealing with is malicious, that the hashes themselves correlate to malware that's being used in the wild. However, it could be. So it's a tough situation. You really need to take that hash and then use some third-party sources, something like VirusTotal or Total Hash or hybrid analysis to perform a deeper level of investigation.
And in this particular case, I created a free account on hybrid analysis and added that account to my passive total account settings in order for it to pull in those results and see it. And with this, you can select one of these hashes and click on it. It will open up another tab and give you the information about that particular hash.
Yeah, and so what's nice about this particular integration that we have with hybrid analysis is that the presence of hashes simply doesn't stop with the hash value. We can actually link over to a report that's going to give us a complete breakdown of what the malicious code was doing on a computer and how that network infrastructure was related to the piece of malicious code.
Right, even screenshots and even the ability to see what communications were happening associated with this particular malware. So that could be another signal that we can use then to look at our analysis and bring that into our project, for example.
That's correct. And so the mere presence of seeing hashes inside of the community platform does not necessarily indicate what you're dealing with is malicious. In our particular case, simply clicking over that hybrid analysis report, they've classified that as malware. And so knowing that that's malware and that ARPANET-network.com appears in it, I can be reasonably safe in saying that I think ARPANET-network.com has either been compromised or it's malicious. And so again, something to keep in mind with hashes, the presence of them is certainly interesting, but not necessarily indicative of being malicious. And then second, we do have some timing information here from our partners as well that let us know when it was collected. And so in this particular case, we can see that these pieces of malware, or in this case, the hybrid analysis reports associated with them, occurred back in February 27th, and that we can actually see in some of the data that we've been collecting on the within our heat map that the infrastructure has only been around for just a couple of months.
Around the same time.
Yeah. So that gives you some correlation between those two.
And it's like what we talked about, how sometimes the newly observed domain might be just stood up to do something bad. This might be a good example to be able to show that it was brought up at that time and was used for something that was malicious.
That's correct.
Let's go back to passivetotal.org. Okay, here we go. And let's go to open source intelligence.
Okay. So when you're in the platform, one of the tabs that you'll commonly see pop up is OSINT. And OSINT stands for Open Source Intelligence. And this is just information that's publicly or freely available online is able to provide us some additional context. And so the trick behind OSINT in our case is that we actually have a custom Google search engine that is being used to search for a subset of security-based websites and other parts of the open web. And that when you're running queries on community.riskiq.com, in this case for passivetotal.org, we are then going and putting that query inside of our Google custom search engine and sending the results back to you inside of the interface. And so within the OSINT tab, we're going to get the source, a direct link, and then tags associated with the information that we were able to collect. And what I find particularly valuable with this information is that it just helps me tell the story sometimes. Passivetotal.org, if we knew nothing about it, the open source intelligence repository, or a tab in this case, is giving us a number of leads to other websites and some indication of, there's a blog, that there's a help website, there's an association to riskiq.com. GitHub, there's maybe code that's been written around this service. There's a Crunchbase profile that might tell me more about the company itself or just indicating that it's a company. And so open source intelligence, one of the jokes that we used to have as analysts was, why don't you go Google it? Mm-hmm. Well, that's effectively what we're doing here. And you can see that Googling gives us more context than what we had before. And when we're dealing with something malicious, we run the benefit of potentially getting open source intelligence that a security company may have found this malicious infrastructure, or maybe there was some sort of obscure virus, website or sandboxing website that ran malware that referenced the infrastructure we're looking at that we didn't pick up through one of our hash relationships, our partners. Mm-hmm. Maybe they missed it, but Google and their indexing found it. So the open source intelligence tab is a great way to help tell a story, to help get a narrative around what you're looking at. When looking at the data source itself, you want to be keen on, is there any information showing up? If there isn't, then you got to dig a little bit further. But if there is, it's always worth exploring what is coming back. But it doesn't really stop there. You kind of want to look at the source of information as well. Mm-hmm. And much like you're evaluating the news that you're reading every day, you need to evaluate the source of information that is included. That's giving you this open source intelligence.
And maybe even the number of sources. I know that we have an example that we'll do as an exercise where you have an indicator, and if you go look at the open source intelligence, you can find out who the threat actor is right away.
Yeah.
So it's a way to jumpstart your investigation, to be able to reference this to see, oh, I had this one indicator, but that's really part of this big threat actor group, and that's now you know that you might be under attack from them.
Yeah, it's really a good way to short circuit an investigation where, I love going to the open source intelligence tab right away, especially when I'm dealing with something new, mm-hmm. simply because I love doing the work of the analysis, but if I can build off of someone else's foundation, that's just going to save me time. Mm-hmm. And as a defender, that's really what I'm concerned with. How do I make the assessment quickly? Because I have either my boss or someone who's depending on me to make that decision. Mm-hmm. And the open source intelligence tab can really do wonders for that. We don't actually bring in any sort of date information associated with the sources of intelligence. So I would say that when you're exploring the open source intelligence links from our platform, you have to go through and be mindful that there is no date information associated with these. And so you could be looking at a report that is maybe 10 years old, or it could be 10 days old. So just try to find that timing information so that if you're looking at a particular piece of infrastructure and you're only focused on this period of time, you want to make sure that open source intelligence is lining up with that time frame as well. So one of the first examples that we're going to be doing here is taking an email address that we know is associated to malicious activity, and we're going to be searching for that within community.riskiq.com to figure out what else we can identify here.
So if you had a laptop that was infected and you associate it with an IP with a email address, and now you want to investigate it to see what's the scope of this and find out what's happening.
So what we're going to do is we're going to punch that email address into our Discover search, and we hit enter. And what we come up with is two unique domains. It looks like wada-arna.org and then taz-cas.org. Now at the surface, all I know is these two domains have been registered with the same email address. So we're leveraging our WHOIS data set here to make this association. We can see that they were registered in 2016 and that they expired, or they will expire in 2018. So they're still valid as of today. Now, my next steps as an analyst would be to investigate each one of these independently. What else is there?
So if we right-click and you open in another tab, we'll see the results.
And so we can see here right away from a visual perspective, there's actually no information. So it doesn't appear that this domain has been resolving the past 6 months. But there is some hosting history here that shows us that we have some passive DNS information. Naturally, we know that we could go and explore more of the WHOIS details, keeping in mind that the email address is just one connection point. We may want to go and explore that phone number as well.
If we go back to the resolutions, I want to mention one thing. If you take a look at the IP address, we marked it as suspicious, not malicious, because the IP address can change over time.
Yeah, that's correct.
The domain could be marked as malicious because that's not going to change, but the back IP address can always be changing. So at this particular time, it was malicious.
Yeah. So looking at the subdomains, is there anything else that we might be able to glean here? As an analyst, I now know that there's a number of different unique subdomains associated with this infrastructure, which to me tells me I have a number of different avenues that I could go explore. I might have some more resolution information, some more passive DNS that wasn't available to me on the primary domain that I'm looking at today. But where I really want to focus is that open source intelligence tab, so that OSINT tab here. And you can see the first entry appears to reference our query or something that looks very similar. Mm-hmm. And in fact, it's not our query. It is something a little bit different. It's WADA-AMA instead of ARNA. And you can see here that something clever has taken place. It looks like this domain that we're investigating appears to be a typo squat. And in fact, if we go and actually click on this first entry, we're taken to a legitimate web page for the World Doping Agency. Now, I'm not an expert on, or the World Anti-Doping Agency. Now, I'm not an expert on the infrastructure we're looking at here, but it seems to me that someone was creating a typo squat infrastructure to make themselves appear like the World Anti-Doping Agency. Mm-hmm. Now, if we look and think back to the time frames, it was 2016 when we first saw this registered. There was some scandals going on with Russia at the time. Right. Now, what's also interesting here, too, is that located directly below that legitimate wada-ama.org link is a piece of open source intelligence associated with the security company Threat Connect. And here they blog about Fancy Bear, a Russian cyber operation on steroids is what they call it. Mm-hmm. And
here's the domain.
Yeah. Listed. And in fact, we have another domain that we did not make through the connection. So we have this wada-awa.org that was not connected through the email address that we originally started with. So this is a great example of a case where we had an email address, we didn't know anything about it, we walk away with two pieces of unique infrastructure. Mm-hmm. Looking at one of them, it appears to be a typo squat of a legitimate website, and then we instantly find this piece of open source intelligence that helps us build a narrative. Not only do we have timeframes that align up to the Russian doping scandals, mm-hmm. but we also have a theme being portrayed in the typo squatted domain, and we always have a complete narrative that we can go and explore further.
And an additional domain to look at.
Yeah. So there's probably a number of other indicators that we could explore there.
The other one are the tags that are associated at the top that the system has put in espionage, Fancy Bear, and Russia associated with this as well. So just by writing the query and seeing it, we can look at the tags as well.
Yeah, and those tags, that's a great point in highlighting those. Those tags are a little bit different in that they're global tags. Mm-hmm. And so these are available to anyone inside of the system, and they're derived from the projects that we have. And so if open source intelligence was a poor lead for us, what we could do is actually explore the public projects that are available and see that there's a Russian espionage Fancy Bear project from the Passive Total team. So that would be another source of exploration if we wanted to go further. Just to kind of round out both of the pieces of infrastructure we were looking at, in this particular case, this taz-cas.org still appears like an anomaly to us. But again, going with the notion that we've discovered the Russian doping agency, Russia anti-doping typo squat, the narrative provided by Threat Connect and the security team, we're able to identify that this is actually a typo squat of the Tribunal Arbitration of Court for Sport. So again, fitting with the theme here, and we can quickly see how just going with one indicator, we can identify a whole bunch of signals that we can now leverage at our disposal and very quickly tell a story about the infrastructure we're looking at. So last but not least, within our traditional data sets, we have something that is specific to the community.riskiq.com platform, and that is projects. And so projects provide the analysts with a workflow capability for them to be able to track the investigation that they're doing and all the artifacts that are associated with it. And what's nice about projects of themselves is that they're going to have a name, a description, they might have tags, and you can actually go through and add collaborators as well. So these projects don't have to necessarily be something you're working on, but it could be something that's shared within your organization or even peers in the industry like we spoke about before.
So there's an aspect of a public project that everyone can see,
yep.
and it's freely open to everybody to look at. And then there's a private project, which is just for you or your organization or the team of people that you've associated with it.
Yeah, and that's correct. And throughout the platform itself, as you're pivoting around on all the different indicators and the data sets that we were discussing, as you hover over particular pieces of information that is valid and can be added to a project, you'll notice a small folder icon where you can click that and you can either add that artifact to an existing project or you can create a new project directly from your search results. And what's great about this is that projects, we've had them in the platform for a long period of time, and we have people that are producing public projects freely for the community. Mm-hmm. And what's nice about this is as I'm pivoting around the platform, much like the open source intelligence tab, where information is freely given to me, that helps me tell the narrative of maybe what I'm looking at, the the projects tab can do the same thing. If I'm looking at a piece of infrastructure that's unknown to me and I see that there's public projects associated with it, maybe when someone else has done all of the heavy lifting to do the investigation, they've procured all of the indicators of compromise into a project, and maybe they've even gone as far as putting a description with a link out to their research. So projects are a great way to really collaborate amongst your peers, keep yourself organized, but it can also be a great way, again, to short circuit what would typically be a pretty long investigation and really get you up to speed on what you're looking at.
So it's like a constant monitor for open source intelligence to see what's happening.
Yeah, and it's also a great way to retain the institutional knowledge from your organization. I don't know how many times when I was conducting an investigation that it would be infrastructure that I had seen 6 months ago, mm-hmm. but I couldn't remember who the threat actor was or how it changed or what their tactics were.
And another nice thing about the project is there's a history involved with it. So if there's a new member that comes on the team or you invite a new analyst to view the project, they can look at that history and get up to speed to see how each indicator was found and when it was added to the project and by whom.
Yeah, that's I think one of my favorite elements, that not only is the project feature itself integrated directly into performing an investigation, mm-hmm. but all of that little bit of contextual metadata about what you were looking at, the time, who looked at it, and when it was added, all becomes extremely important, especially if you're not able to communicate with your peers all the time and hand off that investigation. And so projects almost become self-documenting. Using those, you can share that information out. Even if you keep it private, it's just having all that institutional knowledge in one spot.
So it's a good way for the junior analyst to even go up to speed. We have feature projects within community.riskiq.com, which somebody can go look at a project that we've looked at and said, hey, this is really good, people should be aware of it, to go through that history and see how that progressed and what's happening with those investigations. Again,
that's another great point. We talked about before, the difference between a junior analyst and a seasoned analyst and recognizing patterns, what's bad, what's good. Looking at the feature projects that we have, there's a whole bunch of them that are essentially burning malicious actors in their infrastructure. Mm-hmm. And so if you're new to performing an analysis or you want to apply these methodologies on your own, the projects tab is a great place to start, mm-hmm. Because you can go and look at all the featured ones. You can start pivoting around using all the information that we've already worked up or someone else, our partner, has worked up. And you can begin to recognize those patterns for yourself.
You can even take that first initial indicator and do those searches yourself and see how it progressed and what they did. So then you can look to see exactly what the analyst did.
Yeah, you can retrace their steps.
Mm-hmm. Okay, now what we're going to do is we're going to examine the domain and look at the WHOIS records and create a project with it so we can track it as information comes into the system. We're automatically alerted when something new comes in.
Yeah.
So we're going to search for toyspinners.com.
So the purpose of what we're trying to do here is projects within Passive Total provide a workflow capability where as we're conducting an investigation, we can add artifacts automatically to this project and keep ourselves organized. So right up top, Benjamin's ran the toy-spinners.com here, and we have a number of search results that are available to us. Now, keeping in mind, from the interface visuals and everything else, there is one visual on the top left-hand corner here where it's a little folder. So we have a little folder with a plus icon, and when we hover over that, we have the ability to add this artifact directly to a project. Now, in our case, we have two different projects that have already been configured, but depending on your account status, you may not have any projects yet. And so directly from this interface, you can actually create a new project. And we have a couple different types. We have public projects, which are available to anyone.
Right.
Anyone can see that. And as in the future, as someone's pivoting around inside the platform, they could see your public project. And then alternatively, we have the concept of private projects. Now, depending on your account status and whether or not you're an enterprise customer, you may not have, you'll have a finite number of private projects available to you, whereas the public project side, you have basically an unlimited amount.
And if you're doing an investigation and trying to keep it private, make sure you make that change. Otherwise, everyone will see the information that's in there.
Yeah. And so when it comes to projects, we have the concept of giving it a name, a description, some tags. We have the owner, which in this case would be ourselves. But there's a bottom field here that is also pretty important, and it's the concept of collaborators. When we built this workflow concept, we wanted to make sure that anyone would be able to add a collaborator to their project and their investigation. And so regardless of whether or not you have an enterprise account or that person's within your organization, you can add email addresses to collaborators as long as they're a valid RiskIQ Community Edition user. You'll be able to communicate with them.
And it's the way that you'll share with other analysts outside of your organization to share information.
Yeah, so if we wanted to, we could actually add this artifact to our project, and we're going to get a nice little notification up top that told us that we added the artifact. And what's great about this is that it just gives us some indication that the information was added. And then behind the scenes, there was some contextual data that was sent over as well.
So if you came in here, you can come into to the WHOIS information directly from here and add to a project, and here you can add as well. But if I wanted to just go directly into the project, there's a little arrow to the right, and if you click on that arrow, it actually will open the project for you automatically.
Yeah, it's a convenient way that if you're not sure whether or not you've already added an artifact to the project, it's not going to go through and duplicate it, so you can rest assured there. But if you want to just quickly understand what's in the project as of today, you can quickly pivot out to it. And so the project that we have here is this sample project where we've given it a tag. Benjamin's the owner. It's public, so anyone can see this. And what we've actually gone through and done is added a number of details from the WHOIS record where we just hovered over those items and then hit add to project. And you can see here that Benjamin's marked as the creator. We get a little bit of date information as to when it was added. And then some context here too is if we hover over this, we can see that this Hildegard Gruner name from the WHOIS record was actually added while we were viewing the toy-spinners.com domain and the WHOIS tab. So this is really helpful information, especially if you're picking up this investigation from one of your peers or someone in the organization. Having that small bit of context is extremely helpful.
And the project history is wonderful to be able to go back in and understand exactly how this investigation progressed over time.
Yeah.
What was added if something was removed. You actually see exactly who did it and when it happened. So when you work with a team, it's wonderful. So then you can see what your teammates have done and where they are in the progress of their investigation.
Yeah, it really helps to make sure that you're not duplicating efforts and that you're really transitioning some of that investigative aspect. One of the nice things that we like to point out with projects is the ability to manually add artifacts. So if you're pivoting around inside of the system, it certainly makes sense to add artifacts while you're doing your investigation. But there might be some cases where maybe you're looking at an open source intelligence report and you already have a number of indicators.
Correct.
Using the manual add artifacts menu, there's a number of different artifacts that you can add here, and you can simply paste them into the dialog. There's two artifacts that I think are worth pointing out, and both of those begin with the word keyword. And so that's keyword WHOIS and keyword passive DNS or PDNS. So both of these keyword artifacts are essentially ways in which we could say, look for a keyword inside of any new passive DNS domain that we observe in all of the RiskIQ data set. Or look for this particular keyword in any WHOIS record that RiskIQ processes going forward. And what I love about these keyword-based keyword artifacts is that it allows me as an analyst to put in something that I might find interesting or unique and make sure that I'm alerted to it in the future.
You can even put in your own domain to see if anybody's buying a typo squatted domain or something that's similar, perhaps.
Yeah, now it can very much quickly get to a point where it's difficult to scale. So if we're looking for the presence of the word spinner in any domain that RiskIQ observes or crawls going forward, chances are we might end up with a lot of results. But That's for us to figure out. And one of the benefits that we have here after adding that keyword is we have the ability to essentially turn on our monitoring, and then going forward, every day when we're doing our batch analysis processing, anytime we observe something new, we'll update your project. You'll have an alerts tab, and then you'll also have emails that are sent to you on a routine basis that covers what's changed for the project. So this really goes back to the concept of threat infrastructure analysis not being just a static approach, that it's dynamic.
So instead of having to run the queries every single day to see if there's something new that's appeared, if you create a project and you have the monitors on, as the data comes in, that automatically flows into the project, and it's in the history and in the alerts tab.
Yeah, so not only do these projects act as a knowledge base for you and an ability to kind of share information with your team and really centralize your investigations, but they also have the ability to kind of continually inform you over a period of time. And it's not uncommon for me to even go to the projects that we have that are featured, that we've created, taking a look at them and just seeing all of the different information, all of the new alerts or changes that the infrastructure had. And for anybody who's interested in that, you can simply view the projects page, and you have the ability to see all of the public projects, both featured and non-featured. By default, we're going to show the featured ones. You have the ability to see your projects, things that just created by you, and then you have the ability to see shared projects, maybe between you and some sort of collaborator, either inside your organization or outside. And so I would strongly encourage you, if you're new to the analyst world, or even if you're new to the RiskIQ platform, to strongly encourage you to take a look at the public projects that are there. This is information and research that we collect from the open source world, where we can see all of these rich projects that have already been done by other security companies or individuals. And so if you're trying to figure out how to best start using the threat infrastructure analysis methodology, this would be the great place to do it.
And by examining the project history, you can see exactly how these analysts did their projects. So you can learn from those projects to improve your skill sets.
Yep, that's a great point. Okay, so we just wrapped up the traditional data sets where we looked at passive DNS, who is information, hashes, and a couple of other available resources to us. And really what I think is a great example here is this news.googlesoftservice.net for really highlighting the value of those data sets.
The traditional data sets.
The traditional data sets, correct. Yeah. So just looking at those and isolating our investigation to just using something like passive DNS and who is to really form all the connections that we can. So I think this is a really interesting example here where when we run the search, we can see that the infrastructure still appears to be active. It's only been around for about a year now, and we have some information available to us. Right away, what strikes me as interesting is that there's a number of different Korean addresses, IP addresses that are here in passive DNS, and actually a nice example here of a non-routable address too, that 127.0.0.1. I mentioned previously that sometimes actors will go and turn off their command and control when they're finished running their operations as a means to not draw attention. When in reality, that signaling that they're doing is actually drawing attention to me as an analyst. So that 127.0.0.1 instantly gets me interested because it makes me feel like this might be a malicious actor. Mm-hmm. So if we were to pivot, let's say, on one of these Korean IP addresses, let's say the first one, that 115, 144, 238.49, we can then see that we have some more infrastructure that's not necessarily as active. In the past month or so, it's dropped off in activity. But again, looking off that pivot of IP addresses and passive DNS, we now have 3 different domains that we can go with. So keeping in mind that we started with googlesoftservice.net, we now have googlebuilder.net, googlecustomservice.com, and googlebills.net. So we just went from one connection point, a couple of different IPs, to some other Google sort of themed domains that we can go off of here. Now, for me, there's a number of different avenues that we could go down. And one of the complications that infrastructure like this introduces is you got to pull a whole bunch of threads. Right. And so we have to focus our search here. And I'm going to, in reality, what I would typically do is explore each one of these and follow it all the way down to its conclusion.
You get a dead end, and then you have to go back up to the top and go back.
For the sake of the example here and what it is that we're walking through, we're just going to go through the infrastructure in a very linear way and just talk through each of the steps. and then we'll kind of wrap up with all the connections that we've made. So we have this game.googlecustomservice.com. If we go and pivot on that, what we're going to see here is, again, some lengthier history. So this appears to be an older domain. We see
it's all 127.
Yep, the inclusion of our 127.0.0.1, a tactic, again, leveraged by actors in some cases. I can't quite remember if the IP address is different, but we do have a common theme here of Korean IP addresses showing up. Mm-hmm. But for me, instead of focusing in on the passive DNS side, I want to take a look at the who is information. And so right off the bat, from an analyst perspective, I get a number of unique things inside this who is record. I got 2 email addresses that appear highly unique. The names themselves even appear pretty unique as well. And so does the organization. And so from an analyst perspective, I could go down any number of these leads, but I want to focus in on the phone numbers. We have 3 different phone numbers here, one distinct one for each section of the who is record. If I pivot on one of those phone numbers, what I'm going to get is another lead here. And so I pivoted on one of the phone numbers as part of that record, and we see our original googlesoftservice.net was associated with that phone number, but now we have the inclusion of another domain, appleadwords.net.
And another email address.
Another email that we could go and explore. So if we go and take a look at that appleadwords.net,
it's a 127.
All right, so we got a 127.0.0.1. So from a passive DNS perspective,
it's always been at 127.
Yeah, that's not going to help us too much. Yeah. It's been there, in fact, for a number of years. Like it's not even clear what this particular infrastructure is associated to. If we look at the who is information, there's a lot of, again, unique information we could go off of here, and we could continue to pivot. However, I want to explore some of the subdomains. And so looking at the subdomains, we got app, which is pretty common. We got FTP, that's pretty common, www. The one that sticks out to me is this LED1. LED1's interesting simply because it doesn't appear like a common subdomain. I don't know why they would go with it. And in fact, in some of our previous pivots, we noticed that there was a LED in one of the other subdomains as well. So maybe there's a pattern here. So if we go and pivot on that LED1.appleadwords.net, we now end up in a case where we already know that the subdomains is exhausted. We know that who is an avenue that we could go down. But if you remember, appleadwords.net, the domain itself, was resolving to 127.0.0.1, dead avenue. Keeping in mind, subdomains, every single one of those gives us an avenue of research. And so this LED1 is not resolving to 127.0.0.1. It actually has a live IP address, one that we have not seen before. And that to me makes it particularly interesting. So if we pivot on that 98, 126, 218, 141, not only do we have our LED1.appleadwords.net overlap, so we're kind of seeing some tech company overlap here, but now we have a LED1.igooglefiles.com. Again, keeping with the pattern here of tech companies referencing Google, LED1, some overlap in infrastructure, this to me is getting more interesting. And so at this point, I can pivot on this LED1.igooglefiles.com, and I again have the same IP address, so not much of an avenue there. We can look at the who is information. Yet again, we have some more, that Star Street appearing as the street.
And a different email address as well.
Another email address, another fairly unique looking name, Jack. And again, some phone numbers here that we can pivot down. But I could continue to go down this route. Again, a lot of avenues here, but to me what's intriguing is these 19 subdomains. Again, individual points that I could go down that could lead to other infrastructure. And what I'm seeing here is a lot of interesting subdomains that appear to be not necessarily emulating services, but are maybe emulating countries. So we have HK, UK, KR, KS. We have our LED1 showing up again. We have this Firefox updata.com.igooglefiles.com. Even at this point, if I knew that this infrastructure wasn't malicious, that subdomain is so weird.
Yeah.
It doesn't fit a pattern that I'm used to seeing. And that to me is of particular interest. And so if we go and explore a little bit further here off of some of these, going back to some of the infrastructure that we had previously on this game.googlecustomservice.com, we can go and explore some of the other passive DNS that we saw, in particular that 180.150 address. And so going here, we can see A couple other pieces of overlap to infrastructure. Maybe this could be maybe a typo squad of some sort. It's not entirely clear to me. That we could continue to run down. Now, you may have noticed that as we were pivoting through this infrastructure, oftentimes there was a project that was populated that was potentially available to us that we did not necessarily explore. And the reason why I didn't explore that right away is because I didn't want to short circuit the investigation right when we started. But for anyone who was paying attention, you would have noticed that there was a project associated with most of this infrastructure. And the particular project that I'm interested in is this lead Casper published out by Cylance. And so if I click on this project, what I'm going to get is 125 artifacts and indicators that go back to this espionage group that is targeting all these industrial companies. And what's particular to note here is that these actors use the presence of lead in the subdomains when they're setting up infrastructure, a pattern that they sort of give away. And what's interesting is if you actually read this narrative, the blog that's been put out by Microsoft, they shed a lot more details about the actors themselves, who's conducting the operations. And what's great is that Cylance has already put together a pretty extensive project that we can use as a foundation for our exploration.
And even the project history is wonderful to go through and examine exactly how this was built over time.
Yeah, I think that's a great point. And so there's a lot of threads that we could pull in this infrastructure, and it almost seemingly appears endless. I mean, there's literally, tens of email addresses and phone numbers and names and streets and domains and who is and everything else that really makes up the infrastructure itself. And so using a system called Maltego, which is a graph visualization tool, what we saw in that example for Google softservice.net was that it was really complicated. There was a lot of avenues that we could go down and explore, and a lot of potential for overlap. So using Maltego and the free transforms that are available from RiskIQ Community Edition and Passive Total, you can actually map out this in a more visual-friendly format. And so what we did here was we are essentially focusing in on the right-hand side of the graph, whereas the left-hand side was older infrastructure. And what you can see in the graph, even though you can't necessarily read the values, the blue circles represent domains, the little orange card-looking icon represents an IP address, and then the black circle represents some whois information.
Correct, like telephone number, email address.
Yeah, and so with this infrastructure, what was particularly interesting is that the actors themselves were using newer infrastructure. They were continuing to conduct their operations, but there's that one key piece in the center of our graph there that links the left side to the right side, and it's a single IP address where the actors mistakenly have pointed and overlapped their infrastructure, and we were able to find and track all of the activity back to them. So a very cool example, leveraging the traditional data sets that's still relevant today. Okay, so we just wrapped up the traditional data sets, which covered passive DNS, whois, open source intelligence, hashes, projects, subdomains, and DNS. It's a lot of information. And you'd think that that would be absolutely all we need in order to conduct investigations and really break open actor infrastructure and find the bad guys.
But the threat actors know how we gather that data, how those sets work, and they try to evolve. So our data sets have to evolve.
Absolutely. So what we've noticed is that attackers, especially the more sophisticated ones, are finding ways around specific data sets. Now, they're not always getting past all of the data sets. Maybe it's just one or two. But we are noticing that they're taking note of how we detect them. And so as a result, we've had to increase the number of signals that we're collecting. And that's where our virtual user technology and internet scanning really comes into play here in introducing new data sets.
So can you tell me how the virtual crawlers work?
Yeah, so we mentioned this before, but the virtual users are kind of like what our parents might be when browsing the internet, or even one of our friends who's not necessarily security savvy. They function as a virtual user in the sense that they can perform queries in search engines. They can recursively go through those results by clicking around. They can interact with the page, scroll, click on content. And then we mentioned before that we have hundreds of egress points that we can proxy the traffic through, and the ability to emulate or mimic specific platform features that we may want to use just to get extra targeting or make ourselves appear like a victim. And what's particularly interesting is that not only can the crawlers do all of this work, but they're powered by some pretty complex policies in the back end of RiskIQ's portal. And so we can do a lot of different ways of controlling these policies and how our crawlers function. And then last, but I've mentioned this before, is that we're really working with a headless browser here that's been instrumented. And so all that really means is that much like when you browse the internet and you're viewing web pages, all of that information that's both available to you visually and then everything that's happening behind the scenes, all that information is collected and stored in RiskIQ servers.
So if the threat actor is trying to find, people going out and crawling, they don't detect us because we act like a real user would on the internet.
Yeah, we're not going to necessarily, identify ourselves as RiskIQ crawling service. Please let us in. We go through a pretty complex process to, emulate the operating system that's being used. In some cases where we're going after and we're scanning for particular mobile applications, we'll actually egress through mobile networks that are actually connected to a real SIM and a network that we think is going to be best targeted for what it is that we're searching for. And so one of the questions that we often get asked by customers is, well, I can just go build a crawler myself. Why do I have to use the virtual user technology? Well, I think you hit on that a little bit around how it is that we're identifying ourselves or how we're not identifying ourselves. I think that from a perspective of a security company or someone who's trying to identify attacks, having the ability to make yourself look like any specific technology platform or come from a specific location and go the extra steps of scrolling on a web page and clicking around a bit really does emulate the behavior of a user as opposed to what might be perceived as a security researcher.
But even the scale at which we can go out there and collect this information, a company, they wouldn't be able to do this. So.
Yeah, it would certainly be pretty difficult. Doing billions of HTTP requests a day and then not only processing that information, but also storing it in a way that we can search for it is certainly a challenge. And so when we ask about, especially when we're talking to customers about some of the capabilities that the virtual user technology provides, one of the great benefits is for cases where the attacker has become sophisticated enough that maybe their payloads are only being delivered to a certain region. So maybe the company has a global presence and maybe their German website was compromised and it is now delivering malware that is targeting just the German users. Well, if their United States office, where maybe the security team is located or the primary security team is located, is going and exploring that, if they're accessing that from a United States IP address or network, chances are high if the attacker has put in geofencing on their attack, they're not going to see anything malicious. They're going to see a clean page and they can simply say that that was a false positive. They don't understand what happened. But by having this virtual user technology, we're able to not only crawl our customers' infrastructure, but we're able to crawl all different parts of the internet in a very unique way that allows us to often get attacks delivered to us more often than not.
But even like when some of the Black TDS, some of the hackers that will check out the machine before it sends it to the malware, our headless browsers can mimic those types of things, so those things will play and we'll see them.
Yeah, so I mean, we go beyond just country and language pack. In some cases, we know that malware is sophisticated enough that it'll detect the presence of a specific cookie being deployed before the malware will be served. And our crawlers are able to kind of retain those sessions, have the cookie stored, replay that information. They're really powerful. So it's not just a browser that goes off and crawls things. It really is like a virtual user. So to really understand what our virtual users see, I think it's helpful to get some understanding of just how our backend looks like and some of the information that we're collecting, especially as we go into these derived data sets or crawling data sets. It's helpful to understand what the basis for those are. So when you visit a web page, in this particular case, we have a screenshot of passivetotal.org on the screen. What you're seeing here is an application that's been rendered for you. What you may not have seen is that there were hundreds of web requests that took place and a number of different actions that helped construct the application that you're interacting with. So viewing a web page is not merely viewing a web page. There's so much information that is delivered to you by viewing that page.
It's what's coming in and what's going out. So you might have images coming from other websites and you might be sending data out to trackers like Google, for example.
Yeah, that's completely right, and that is the case when you visit passivetotal.org. And even more so in this particular example, our application itself is a single-page JavaScript application using a specific framework called React. And that is a client-side framework, and what that means is when you view our web page and you look at the source, there's really not a lot going on there. Essentially, what's happening is your web browser is taking that source information and then using JavaScript to essentially construct the application inside of your browser. So viewing the source is going to be completely different than the actual application itself. So there's a lot of changes that take place there that are very seamless and hidden to you as the user, but from our virtual users, we get to see every change that takes place.
So you get to see how it's constructed, all the links, the dependent requests, the cookies that might be involved, the certificates that are seen, all that information is stored and understood.
Absolutely.
So let's go on to the response and document object model.
Yeah, so this is a screenshot of our backend, and what this is essentially showing is just the raw content that comes back. So like I was just saying previously, when viewing the web page itself, viewing the source, the actual response body of the page, may be very bare and minimal, especially in a single-page JavaScript application like passivetotal.org. But once it's actually rendered out completely, there's a number of different changes that take place. So not only do we get the response body, we also get all the individual changes that take place as the web page is being built. And it's from this information that we actually go and derive some of the crawlers, where we're able to pull things out of the web page specifically. So the presence of a Google Analytics tracking ID, or the presence of specific links, or certain technologies that are running within the page. So it's that response body and document object model that really power a lot of these derivative data sets that we have. So one of the other items that we see as well, obviously if we're getting the response body and document object model, we're able to construct what links are present on the page by looking at the A elements for the HTML. And what we have here is just we're able to extract those components directly out of the page content. And I think it's worth noting too that we even have the XPath information. And what that is basically telling us is where that specific HTML element is occurring within the document object model itself. And if you're thinking about how this could be useful in the long run, how we can derive some interesting signals from this information, knowing the presence of, if a website was compromised, was the JavaScript injected in the head section of the page? Was it before the body? Was it after the body? Was it tacked on at the bottom of the body? There's a number of different pieces of information we can glean simply by looking at the location of certain elements. So naturally, when viewing a web page, there's a number of different network requests that take place. We're not just getting the content all from one server, or typically we're not. Now, you mentioned before that passivetotal.org might be going out to image websites, like it could be going to Amazon, like S3. It might be going out to Vimeo to get some of the videos, including maybe even this. If it's published on YouTube, it'll reference YouTube. In this particular example, what we have here, we call these concepts of going out to a third-party site or another part of the page dependent requests. And so in this example, we actually have the case where we were visiting http passivetotal.org, and our crawlers were actually redirected through a HTTP 301 response code to https passivetotal.org. We can see that GET request was successful as indicated by the 200 response code. And then we see that there's a dependent request that follows to use.typekit.net. And in this particular case, all we're doing is we're making a JavaScript GET request out to this third-party website in order to get a font. And so these become incredibly valuable because dependent requests help us shape a data set we call host pairs. The relationship between one website and another website observed during a crawl.
The child-parent request, if it's coming in or going out.
Yeah. So we can see when you visit that web page, all of the other third parties that are being referenced, and then we can generally identify the cause that's taking place too. Was it a redirect? Was it a script reference? Was it an image reference? Was there an embedded video reference, and so on? So this information becomes definitely really valuable when dealing with potentially compromised web pages or web pages that are getting injected through maybe malicious ads.
And if you just went to the website and tried to figure this out just by examining the website on its own, you wouldn't see it. You wouldn't be able to understand it unless you had this crawl information to be able to go through and see exactly how it was constructed on the device itself.
Yeah, that's correct. Simply downloading the source of the web page is not going to necessarily give you all the dependent requests that take place, especially if some of those requests are handled through JavaScript. So downloading the source might give you some reference to third-party websites, but it's not going to necessarily show you how an ad is running or an ad being injected in the page and how it manipulates the structure of the page.
And it could even be obfuscated or encrypted inside of there that you can only get to it once it's rendered and you understand what's happening.
Yeah, that's when it becomes really powerful, that the derivative data sets that we'll discuss later, running the web page dynamically goes a step beyond. Static interpretation, there's a lot that we can do with it. It's certainly a valuable resource. But when you have the ability to dynamically execute a web page, you really understand the intent and what's happening behind the scenes. And so I mentioned before that our web crawlers go out and they're able to even maintain sessions. So we're not just going and downloading a single page. We're also going through and literally maintaining sessions in some cases. And cookies, small bits of information that are typically passed from the server over to the client, generally used for tracking state or maybe request information or describing the client. That's information that we get as well. And so in this particular example, we're able to see that passivetotal.org was displaying two cookies. One that is associated with our AWS load balancers, and two, something a third-party service that we use called Woopra, which just tracks usage of the application overall. So having these cookies is immensely valuable because the names can be unique, the values can be unique, and the path in which they were delivered to us can be very interesting.
So like even a marketing campaign, there might be a cookie that's dropped so they can track to see how that marketing campaign goes.
Yep.
And then even we've seen threat actors that might even drop the same type of thing to track how well their campaigns are going.
Yeah, or in some cases they might want to make sure that they're not delivering the same malicious payload over and over to the same security researcher. So by deploying that cookie and checking for the presence of it within, let's say, JavaScript, they know whether or not to deliver some malware. So it kind of goes hand in hand with some of our other data sets. As you can imagine, there's a lot of overlap between these. So last but not least, especially in this day and age where privacy is a big concern, we collect the SSL certificate information, assuming that it's present. So when we're going out and we're crawling a web page, regardless of the port, we will go and actually pull the SSL certificate that is delivered to us, including the full chain, and then we'll save that information. So I think most people commonly observe SSL certificates, or they know to check for the presence of them by looking for a lock inside of the browser. And then this particular screenshot that we have, it's just showing the certificate contents itself that is something you could see directly through the browser. For us, we're getting a data representation of this. We're not only taking note of the certificate and all the unique details, but we're also taking note of when and where we observed it, which IP address was hosting it, what domain was serving it.
And even the information inside of the certificate, the name, the country, the organization, all those are stored as well. So we can pivot off those and find relationships with that as well later on.
Yeah, that's correct. And we'll go into a deeper example and set of questions that you might want to ask when looking at this data set in the next session. So we've collected all this data. We now walk through what our crawlers are seeing in the background, our virtual users, and all the information that RiskIQ is collecting and storing. Simply handing that information over to an analyst is not going to be that valuable. It's way too much information to consume. It's going to be difficult to parse this out, especially if you keep in mind that we may crawl a web page hundreds or thousands of times to see how it changes over a period of time. And so we need to operationalize this crawl data. And I mentioned before that there's these derived data sets or crawling data sets. And that's what we're going to go into now. We know that attackers are looking at things like passive DNS, WHOIS, even SSL certificates, and finding ways around being tracked or leaking out any information that might reveal their infrastructure. And so by leveraging all the information that we have from the crawler and operationalizing these so that it's now a data set that we can pivot on and make connections with, that gives us more signals that we can operate with, which means more overlap, more potential ways to identify attackers if they mess up.
And a higher confidence in making a decision that is accurate.
Yeah, so just instead of having 1 point of proof, we have 3 points of proof. We're able to really substantiate the hypothesis that we might have, or really build out a narrative like we didn't, or like we couldn't have before. We discussed traditional data sets, and now we have these internet crawl data sets, or the derivative data sets that we have from that crawl data. And so the data sets that we're going to be discussing here are SSL certificates, trackers, host pairs, web components, and cookies. Some of these may not be familiar to you because it's names that we made up simply because this data set didn't exist anywhere else. And then some of them might be terms you're already familiar with. What's going to be interesting is that, some of these data sets have a bit of a dual purpose. You may think about SSL certificates in one way, but I think what we're going to be revealing in some of our methodologies is that there's other ways that you can use this data, especially when you store it at scale.
So now what we want to do is we want to examine certificates. So let's go out and search for www.passivetotal.org so we can see that certificate information.
Okay, great. So SSL certificates, I think most people are familiar with these because they're trained to look for the lock inside of the browser that tells them it's secure. In order for that secure to be there, an SSL certificate needs to be in place. And it's essentially a cryptographic set of keys that establish trust. And there's a protocol that negotiates the presence of the keys with the client and the server, and then provides an encrypted session. So one of the interesting traits about server certificates is that there's details in which that describe them. So you can get a certificate from, you can issue one yourself, or you can purchase one or issue one from a certified issuer, if you will. And so if we expand the certificate tab, the first entry here, we can see a bit of what's typically found within a SSL certificate. We have times for when it was issued, when it expires, a unique serial number that's provided, the version for the protocol that it's going to interact with. And from an analyst perspective, where we probably want to pay attention is the common name. Common name essentially describes the website that the certificate was issued for. In this particular case, this SSL certificate was issued by Thought, the organization, and that's a provider that we can purchase certs from. And it's only valid for www.passivetotal.org. The rest of the information is sometimes there and typically not too useful. But as analysts, again, keeping in mind what we're looking for here is unique details about a certificate. The serial number could be something that's particularly interesting. The common name is certainly interesting to us. We know that in this particular case, by searching for www.passivetotal.org, we now have 3 entries in 3 different SSL certificates that have been associated with this infrastructure over the course of several years.
Now, if it was like a wildcard certificate, it wouldn't have the www.passivetotal.org. It would just be star.passivetotal.org.
That's correct. And so in some cases, you may not see the certificate tab when viewing domains, but you'll also note here that there's an infrastructure column within this within our tab as well. And that infrastructure is calling out specific IP addresses in some cases. Now, I mentioned before, there's 2 different ways that we could think about the SSL certificates. The first is the encrypted session and the concept here that we have on the left, the details of the certificate. Now, what's particularly interesting is, in order for an SSL certificate to be displayed to the user, it needs to be hosted somewhere.
Right.
It's not going to be hosted on a domain, it's going to be hosted on an IP address. And so if you remember and recall, RiskIQ is doing routine internet scans of the IPv4 space and probing a number of different ports, over 100 different ports, and pulling back that information. Some of the information that we're pulling back in this case is SSL certificates. And so what we're able to identify, A, is not only the certificate itself, the contents that we see here on the left, but we can also see all of the other IP addresses in which we've observed this unique certificate being hosted on. And this becomes really interesting because as an analyst, the certificate might have useful information that I can pivot off of. But the infrastructure might reveal other pieces of hidden parts of the attacker's infrastructure that wasn't visible to me.
Or it could be other certificates hosted on those IPs.
Yeah, correct. So to me, what's really interesting from the SSL certificate standpoint is the fact that there's a lot of different ways you could go about approaching it. Is the certificate signed by an actual issuer, or is it self-signed? Does the issue and expiration line up? Is it expired cert that's still live? Is there a serial number that has overlap to other certificates? Is the common name a wildcard, or is it for a specific subset of domains? Is the infrastructure hundreds of IP addresses that share that same certificate, that's probably not as interesting. Whereas in this particular case, we're only looking at a handful of IP addresses. And so there's a lot to consider here when looking at SSL certificates, but it's definitely a really unique data set that we have, and it's very interesting.
And you can even look at the issuer of the certificate, because sometimes they're associated with bad people buying those certificates.
Yeah, and it's seldom that we come across that, but there's been an increasing number of ways to get certificates today, where we're seeing an influx of providers similar to like Let's Encrypt, which allows you to register for SSL certificates for free. And every 6 months, those will expire, and you reissue a new one by validating yourself. So we are seeing a case where what I would have said in the past is, an attacker's not going to go through and purchase an SSL certificate. It's just not, it doesn't make sense for what they're doing. With services like Let's Encrypt, attackers are now able to procure SSL certificates for free, and it adds to the legitimacy of their phishing attack. What I find particularly interesting about the notion of a service like Let's Encrypt is it does make it more challenging for the analyst to identify maybe what's going on or prove that a website's definitely malicious. Like I said, the presence of that lock, we've all been trained to recognize this is a safe website.
Right.
But what I like about the Let's Encrypt concept is that every 6 months, it forces you to go and re-authenticate that certificate. And so what that can tell you from a signals perspective is if you continually see the same certificate getting renewed month over month, then it can tell you that that infrastructure is still being leveraged in some form.
So with Google Chrome coming out with very soon to say you have to have a certificate on the website, or we're going to say, hey, it's bad. Very soon, we're going to see that happen more often, that these websites are going to have certificates. And if the certificate only lasts 6 months and it's gone and it's burnt, then hey, that's also potentially something bad as well.
Yeah. The change that you mentioned within Chrome will not flag the websites as bad, but it's just going to indicate that they're not secure.
Yeah.
Which at this point in time may as well be considered bad. So I think you're going to see certainly a rise of SSL certificates, and that's great for us because there's a lot of signals in them.
Yeah, we'll be able to link it all together.
Okay, so the next data set that we have here is something we call trackers. And this definition was something that we initially came up with, but we're increasingly seeing this in reporting today, especially around services that are maybe tracking users as they browse web pages and potentially invading their privacy. And so trackers are essentially unique pieces of information commonly associated with analytical services or social media services that are going to be embedded within a web page and its content. And so commonly what we would say that, what a lot of the trackers that are fairly well known to people are things like Google Tag Manager, Google Analytics, Twitter IDs, Google, GitHub IDs, New Relic.
Clicky ID.
Yeah, Clicky Mixpanel. Anytime you have some sort of marketing-based content or tracking-based software, we're going to essentially have a tracker for it, be able to extract that out. But with this data set, what's particularly interesting is that in order to get it, you have to have crawled the web page. And it's either you've viewed the source and you got the response body, or you actually constructed the application completely by rendering the full page dynamically. And we're able to extract these items out. So looking at the trackers associated with www.passivetotal.org, we can see here that we have a couple of Twitter IDs, some GitHub IDs, Google Analytics IDs, and Google Tag Manager. Now, what's particularly interesting is that PassiveTotal.org uses Google Analytics to track the engagement on our webpage. And what we're given is a unique multi-digit code that essentially tracks the activity for our properties. And if we want to segment out our properties, we can do so by cutting a new version of that code, as we can see indicated in some of the examples we have here. Now, what's interesting is that these are pretty unique. They're unique to the customer. And we're able to leverage that from an analytical perspective because we have a database of them, and we have a number of times of the first time we saw it, the last time we saw it. And so what I like to use trackers for is the ability to, one, identify if there's a web page that RiskIQ has crawled associated with what I'm looking at. Two, what technologies or what tracking codes are present on this web page. Are they deploying, a whole bunch of different services and all these different libraries, or is it just a couple of them, or is it none at all?
Another cool thing that I've seen cookies, the trackers used for, is looking at your own infrastructure, because sometimes when somebody does a phishing site, they'll copy your website, and they'll copy everything, including your own trackers. So now your trackers will be on their site, and you can pivot off of your own codes to see relationships that you weren't aware of.
Yeah, I think that's a great point, that actors might be sophisticated enough to copy your web page and replace out the form and set up a command and control infrastructure, but they're probably not thinking about that Google Analytics ID or that social media account that was buried in there, and our ability to connect those two dots. To me, that's one of the common ways in which we can pivot on top of this data and really begin to understand some of the relationships. And what I particularly find useful is something like you just said. If I'm a new analyst and I want to figure out, maybe what a good example of malicious could be, we could punch in paypal.com, go to trackers, filter it down to Google Analytics IDs, and start exploring that, because chances are pretty high, PayPal being a heavily phished brand, we're going to find some typo squatted and phishing websites right away. And so when it comes to trackers, what we want to look for here, again, is the time. How often are these trackers coming up? Is it a whole bunch of trackers all at once? Are they changing frequently? Is there any unique trackers inside of the page or interesting components?
Sometimes we've seen that a tracker might only be available for a very short period of time. And that might be an indicator of something potentially you need to look at, because it was only up for a couple days or a day or so.
Yeah, it could indicate that maybe the web server was briefly compromised, or that attackers were trying out a new technique to see if anyone would notice that the web page was changed. So it's certainly an interesting avenue. And what I particularly love about trackers is the fact that we retain all of this crawl information, and the way in which we're extracting these trackers out is a number of complex rules. Sometimes regular expressions, sometimes pattern matching, sometimes automatically derived based on like the data science techniques that we have. But what I love most about it is, in the event that we find a tracker that is really useful that we don't have any rules for, we can write a rule and then apply it back to all the information that we have and instantly gain an understanding of how widespread the use of that tracker is, or help us kind of really open up an investigation. So trackers are something that are always evolving, they're always changing, and they're definitely an interesting data set to keep your eyes on. So we've brought up the concept of trackers, SSL certificates, and just to, again, kind of come back to our common way of visualizing this information, if we look at the response and document object model that we're collecting from our virtual users, we start with that DOM, and then we're able to pull out the trackers through rules and other unique combinations of how we get that data. And then from that, we can identify other domains that are leveraging that same tracker. Maybe it's a Google Analytics ID, a New Relic ID, Mixpanel, etc. On the SSL certificate side, we got that two-pronged approach. One, we have the certificate concept, the certificate facets, if you will, the contents of the certificate. And we could use that to identify other SHA-1s or certificates associated with the particular facet. And then we have the infrastructure side of it, identifying the IP addresses in which the certificates were hosted on, and then using maybe another data set like passive DNS to run to get all the different domains that were ever associated with those IPs.
And enrich that information to give you a complete view.
Yeah, so just, again, keeping in mind here, like with the infrastructure chaining concept, being able to put these different data sets together, and we're showing very small examples here, but the infrastructure chain could be massive. I mean, it could be highly connected, and it would just be a massive block of connections and a ball of yarn. So again, increased visibility that we have with these data sets. With the case of host pairs, we're looking at links, sequential data, and the dependent requests that we spoke about earlier when our virtual users are fetching a web page and observing what happens when it dynamically runs.
What's coming in and what's going out to a domain, for example.
Correct. And so from that information, we derive that host pair, the parent and the child, the cause between them. And using that information, we're able to make connections from one domain to another because of the dynamic nature we observed when our virtual users ran the crawl.
So if malware is being brought into that website, and rendering and that on that person's machine, you'll see that request coming in, and you'll be able to link it together to show that relationship.
That's correct.
That you normally wouldn't be able to see if you just looked at the source, for example, on the page. You might not see that.
That's correct. So looking at host pairs, this is another data set that we've sort of coined our own term because it didn't exist. Essentially, what host pairs are is two pieces of infrastructure, a parent and a child, that were observed being connected dynamically when our web crawlers crawled the web page, our virtual users crawled the web page.
So this could be like you're having a Facebook image on your website, and that would be pulled in to render on your website.
Yeah, so if we took www.passivetotal.org would be the parent in that case, and then Facebook would be the child, and the cause between them would be an image reference. And so what we can see here in the tab contents is a number of different host pairs in a number of different directions, both child and parent, and a number of different reasons why. So as I mentioned before, these dependent requests may occur because of images, redirections, JavaScript, CSS, a number of different reasons. We're capturing that information when our web crawlers go and crawl the website. And what, to me, this is probably one of the most exciting data sets that we have because it really helps tell a story. What I like about the host pairs is the ability to walk back up a chain of requests or walk down a chain of requests. And so if you think about a web page that maybe has been compromised and there's a piece of JavaScript that's been injected and that's reaching out to a third-party host, and then that third-party host is rewriting the page and redirecting the user through a number of different web pages before delivering malware, the host pairs are able to tell that story. And they can do that by looking at the parent page and identifying the child relationship to the malicious resource, identifying that there is a location redirect that takes place, and then you can pivot over to that resource as the parent now and see where it redirects to, and you can follow that chain all the way down until you get to the malware.
So it's like mapping out the internet. It's mapping out the relationships between all the websites and how they all interact with each other.
Yeah, and so what I think is particularly cool is host pairs can be kind of noisy. You know, there's naturally websites are comprised of a lot of different dependent requests, especially with social media, marketing, tracking software that we have today, co-located images and JavaScript libraries. There's a lot of stuff to wade through. But when a website's compromised, passive DNS, whois, subdomains, and other details will probably fail you.
Right.
Because chances are the passive DNS is legitimate, the whois is legitimate, the subdomains were created by the original website owner, the SSL certificate was certainly purchased by them, and it's only the dynamic nature of crawling that page and observing the relationship of all these dependent requests that we might be able to identify the cause of compromise. So when it comes to host pairs, we want to look for websites that are being referenced that may appear strange or something that's not familiar to us. We may want to look for typo squatting. So cases where the user has compromised the web page and they want to blend in. So they might choose to hide themselves and make them look like an ad service or a content delivery network provider or even a social media provider. But really scrutinizing this information becomes helpful. Also, keeping in mind, again, our friend time, we want to observe cases where was there an influx or a recent change that we observed, where maybe there wasn't a change for a number of years and then all of a sudden we saw that the web page was redirecting to something new that it previously didn't. All those things are important when looking at the host pairs tab and really deriving the story. And then naturally running the pivots themselves. Each time you run a pivot, you're going to get more host pairs. You're going to identify the next step in the evolution of referencing. So if I'm looking at passivetotal.org and then I click on, the fact that we redirect to community.riskiq.com, I may want to know what community.riskiq.com is now doing. So that helps you really build out that story.
Walking up the tree so you can see where you can originate from to get there.
Yeah. So this is an immensely valuable data set and really great for cases when websites are suspected of being compromised, or they've been compromised and they're serving up some bad and malicious infrastructure.
Or to find potential compromise, because you can search for your own stuff to see if there's anybody reusing any of your infrastructure and linking it back together through the host pairs.
Yeah, that's a really great point there. We talked about the case where someone might download my web page and use it for phishing. Well, if I'm a smart attacker, I may not want to go and download all your image resources or your CSS. I might just point directly back to your domain.
Mm-hmm.
So you're right, looking for cases where someone else is pointing their infrastructure back to my infrastructure could really be a good lead to proactively identify people that might be phishing you.
Mm-hmm.
So that's a great example.
So the next thing that we're going to do is we're going to do an investigation and look at host pairs.
Okay.
So we can see the child-parent relationships and the types of information that you can glean from that. So in this example, we're going to look for antivirus.safetynote.xyz. And what we want to find out is, let's say it came through the firewall, and we want to know, is this still up or down, and whether it's malicious or not. And if it is malicious, is there anything else that we should be blocking?
Yeah, that makes sense.
There? So immediately when we take a look at this, we can see that the heat map is empty. So it hasn't been up for 6 months. And if we look at the upper left-hand corner, we can see, hey, the last time it was up in June 21st, 2016. So quite a while.
We got the time bar as well there. It's showing that we can see visually that there was only, it looks like a 6-month, 8-month window that it actually was active.
A little over 6 months. Now, we can go, there's many different avenues that we can investigate, but we're going to focus in on host pairs. So if we take a look at the host pairs, we see parent-child relationships. So if we look at the query is antivirus.safetynote.xyz. And a parent means it is going towards that. So it's sending information to antivirus.safetynote.xyz.
Yeah.
And then antivirus.safetynote.xyz was then going out to a child. So if we look at this, we can see that this track.mcwtg400.com was redirecting, because that's the cause, to antivirus.safetynote.xyz. And then from here, those were redirecting to the children. And those are all typo squatted domains.
Yeah.
So we have like the Wall Street Journal.om, Toys R Us.om, and even United.om.
Yeah, so what's interesting here is that the track.mcwtg400.com, that appears like it could just be that's a random looking domain. Maybe it's associated with some sort of ad affiliate program. But we know that antivirus.safetynote.xyz, we got some phishing tags here letting us know it's malicious. We know it's not active though. But what's particularly interesting is that there's so many different redirections that are taking place to all these different typo squatted .om infrastructure.
And they're all around the same time period as well, when they were first and last seen. They're very similar.
So I'm curious about what's on, like, let's say United.om.
Yeah, let's take a look.
Yeah, because if we know that a malicious website is redirecting to this website, then that relationship can tell us that maybe this is malicious as well.
So this particular website was last seen in March 21st of 2016.
Okay.
So a little bit earlier, it stopped responding. But if we take a look at the host pairs here, we can see 27 parents and 7 children.
Okay, so in this case, we have other potential malicious websites that are redirecting to this United.om,
Mm-hmm.
and this doesn't appear to be the last stop either. We can see some additional child redirects taking place here.
To even further, so it's going from a bunch of domains, going to many other domains, going to many other ones. So
yeah, so this is kind of like a traffic distribution server commonly seen with ad fraud or click fraud or some sort of affiliate fraud. And what I like about this particular infrastructure is that we started off with something that we knew was malicious. We found a bunch of typo squatted websites instantly using the host pairs. And then we were able to go to just one of those examples and then say, show me all other websites that have redirected to here as well. So our one starting point now just became another 27.
Correct.
That we can then go and investigate. And in fact, when you start to pull the strings even further with this infrastructure, you can walk all down different parts of this infrastructure and you develop a massive yarn ball, is what we would call it, of redirections between all of these different websites that's just all occurred around this 2016 period. And it's really interesting, and I think it highlights the benefit of the host pairs data set, because passive DNS won't necessarily give you this information. Whois may not get these connections, and really any of the other data sets are not likely to see this level of dynamic activity.
Yeah, you can only see it when you bring in that document object model and build it to figure out exactly what was happening.
Yeah, and the fact that like its redirect is actually taking place and it's being observed by our virtual user. So a very cool example that highlights the host pairs. Okay, of the last of our derivative data sets, we have something we call components. Now these components are derived from both our virtual users and our full internet scanning, the IPv4 internet scans we run on a routine basis. And what we're looking for with components is we're looking about the technology makeup that we've observed by either crawling the web page with our virtual user or looking at the server stack that we were able to get from the service banners or headers from doing the open port scan. And so what we have here is a list of all these different technologies that are available to us and then the unique value that we've observed. What's particularly interesting here, again, knowing that we have some results tells us that the RiskIQ crawlers have definitely observed this property before. And if we're thinking about a good website versus a bad website, a good website's probably not going to go through and add a whole bunch of components or set up a lot of infrastructure, technology running in their page. Some of them may, but chances are high that they're going to do the least amount possible. What I like in using components is that you can sometimes find some unique information in there. Maybe some unique tracking pixels that have been deployed that are more specific than the generic tracker information. So maybe it's something that is part of the technology stack itself. Another one that I like, and a great example, is CoinHive. So CoinHive is exploded in popularity, cryptocurrency in the browser, mining coins, based on your user's activity. Well, that's a component too. That's a piece of technology that we're able to identify and then simply running a pivot on that value.
And find all the infrastructure that's infected with that or running it.
Exactly.
And there's even Black TDS is another one where you can actually see the distribution network that's being used to move everybody around and listing that component out and seeing everything.
Yeah, so I really enjoy the web component simply because it gives me a little bit of insight as to what the website is running or what the server's running. And when I think about, a website that may be compromised, a great avenue to explore is the components themselves, because not only are we pulling out the technology, in some cases we're pulling out the version of that technology as well. And if you think about a website that might be compromised, maybe it's because it's running a vulnerable content management system. And so using that information, that might help you figure out, maybe that's how the compromise occurred.
Or a particular WordPress plugin or something.
Absolutely. And so to me, the web components are great from an analyst perspective because they give you makeup of the technology that's running. They might leak some information about versions that are being used or technology that's being employed or maybe favored by a malicious actor or even a good actor. And then you can leverage it for cases where there's wider spread uses of technology that might be considered bad, maybe like CoinHive. And so again, in thinking about how to leverage this data set, time. We want to look at time. Are these components changing often? Is there infrastructure or is there new technology that's being added frequently, or is it just staying the same all the time? Are there any fake versions of known or popular server frameworks or libraries? Are there any unique libraries that maybe you've never heard of before?
Yeah, so like if you searched on Apache, you're going to find probably everything in the world. But if you looked for the CoinHive, like you mentioned, you're going to see just that infrastructure.
Yeah, so something that is less frequently occurring, and gives you an idea of what you're dealing with. Another case too is like just having an understanding of like whether or not ad networks have been deployed. Are the bad guys going to do that? Not necessarily. They're going to be wanting to infect the ad networks. So I think components can tell you a story about the makeup of what you're dealing with, and they can also help you validate some of the legitimacy around the website as well.
Even transparent proxies being used on the infrastructure.
Yeah. So the cookie data set is essentially the server pushing down small pieces of information to the client. It's typically used to track state or other details on the client side that's not persisted over to the server. When those cookies are pushed down to the client, they're going to have a name and they're going to have a path in which they were deployed from. And then our virtual users are going to make sure to keep the first and last time that they saw them. So what's great about the cookie data set is that the cookie names themselves can be pretty unique. And we can use that uniqueness as a means to pivot to identify any other websites that we're seeing deploying a cookie with that name.
The same name.
Just like any of the other data sets that we have here, making that pivot to form connections. What's interesting about the cookies is the fact that our web crawlers maintain that session as well. And so as we're being, let's imagine that we visit a web page that is delivering malware and it's redirecting us through a number of websites before delivering us the final payload. What's really interesting about cookies is that if they deploy a cookie from the first web page and we get redirected, and ultimately we get delivered other cookies throughout the redirection sequence, we'll be able to see that infrastructure as part of the domain column, and then be able to correlate that with the unique cookie name that got deployed. So there's two avenues that we can explore here on cookies. One, the unique name, and two, the domain in which it came from. Because it's not always going to be the domain that you're searching for. In the case of passwordtotal.org, we might have cases where we have ad providers or someone else that are pushing cookies as well, and we can identify overlap between, we're seeing double click here. So maybe passwordtotal.org is running some ads of some sort or is part of that.
And if malware is dropping a particular cookie on several different places and it's the same cookie name, we can link that infrastructure together.
That's exactly right. And so from an analyst perspective, what we're looking for here is, again, time. We're looking for unique cookie names. We're looking for cases where cookies are all of a sudden appearing, where the first scene might be in the last couple of weeks. Whereas there haven't been any changes. We also know that cookies might go hand in hand with technology. And so seeing the indication of a particular cookie might indicate that the technology in the back end changed, or the technology makeup in the front end changed in some form. So cookies, while not always as useful, can be powerful connection points, especially since we have observed cases where attackers will deploy their own cookie, like I said before, to determine whether or not they've delivered the malicious payload to you already, and we can use that cookie against them. Essentially pivot on that and identify all the other malicious infrastructure that they used to deliver the same cookie value. So now that we've reviewed all of the derivative data sets that we got from operationalizing our crawling data, let's go into an example of some really complex adversary that we can leverage these data sets to our advantage. So we're going to start with rss.nbcpost.com.
And can you give some background about this, like what happened with this attack?
Yeah, absolutely. So what's interesting about rssnbcpost.com is, one, we know it's malicious, and that it was actually associated with some Russian espionage activity that had went on for about a year and a half, close to 2 years. And essentially what these guys were doing was compromising a number of web pages, and then injecting scripts inside of them that would then profile users who visited these legitimate web pages in order to identify the technologies that they were running so that they could then ultimately deliver some exploits to them. So this infrastructure was fairly complicated, and it was something that grew over time. The rss.nbcpost.com was actually the second command and control that we observed being used by this malicious actor. So, firing this into community.riskiq.com, we can see that it appears to be active as of today. It's resolving to one IP address. Our time bar indicates that the infrastructure has been around since 2016. We do notice an observed gap here, where I could just tell you, for the sake of the demonstration, this infrastructure was actually taken over by a researcher. It was sinkholed is what we would call it, where the infrastructure is basically taken over by good guys, and then instead of delivering malicious content or doing something nefarious, it's then parked on a web page, and those who have been compromised, the operator of the sinkhole can reach out to them. So again, keeping the traditional data sets out of it, there's definitely avenues that we could explore here. We naturally see some passive DNS information, some whois, subdomains, etc. But what I really want to focus in on is the host pairs, maybe the components, the trackers, and the cookies, the things that we get from our web crawling and virtual users. So if we start with the host pairs section here, what we can see is a pretty interesting pattern. One, we know that rss.nbcpost.com is bad. And so what I'm seeing here is a number of parent relationships to these other web pages, which have been marked as non-malicious and have a number of tags inside of them.
So that means that these parents are sending data to rss.nbcpost.com.
Yeah, there's that these sites are making some sort of reference.
And what we've done here is we've tagged these already to say if they were malicious or non-malicious and what type of, it was an embassy or government site. So that's why we're seeing some of these tags here. Because if someone does this on their own, they're not going to see that. But we've gone through and during our investigation have tagged these.
Yeah, that's correct. And as an analyst myself, I strongly recommend doing that technique simply because the capcorporation.org, where I may be familiar with it, or the Zambian embassy, I know that's obviously an embassy, but you get into cases where like you have this Bewaskafen.at, where I'm not certain what that is. Right. And so I actually had to do some research there to identify that it was an agricultural based government website. And so putting those tags in place and then marking the website as non-malicious is really helpful, just to help understand all of the different sites you're looking at. So what's particularly interesting here is we have all these websites, legitimate, non-malicious, reaching out through a script source to our rssmbcpost.com. Right away, my default inclination as an analyst is to believe that these websites are probably compromised. Now, naturally, I know the background information here, and so I'm familiar that, in fact, these sites were compromised. But that doesn't change the data and what the story tells us there. We can see that these websites have the relationship to our bad website. So if I pick one of these, let's say www.NambianEmbassyUSA.org, and I do a pivot on that, again, kind of using our visuals that are present for us, we see that there's activity associated with the infrastructure. It's been around for close to...
Since 2009.
Yeah, so nearly 10 years of activity here. And again, focusing not on the traditional data sets, which are actually not going to net us much value here, simply because unless the website was changed to point to something different, right, the infrastructure is going to be okay, the who is information is going to be fine, the subdomain should be good. Where I again want to focus is on those crawling data sets. And in particular, I want to look at the tracker tab. So what we're seeing here is one tracker that's been deployed on this web page, and it's a clicky ID. Now, clicky ID, like clicky itself, is just kind of a analytics-based service. It doesn't mean too much to me, but what does pique my interest is the fact that it is around the same time of when those host pairs were being observed that we found that clicky ID, and it's the only tracker on here. So from an analyst perspective, I want to go investigate what that is. And so if I pivot on that clicky ID value, I then get a whole bunch of other websites that are associated, some of them being overlapped with what we saw with the host pairs.
Oh, there's a Russian embassy.
So there's a Russian embassy, there's that CAP Corporation again, we got mfa.gov.kg. We have some websites that appear to be legitimate here as well. But what's interesting here is we got a clicky ID that is now referencing some of the same websites that we know we're making a JavaScript reference to something that we know is malicious. So while I'm hesitant to say, but it does appear like this clicky ID, because of the overlap, the Russian embassy and CAP Corporation probably don't have a direct relationship between them, or all these websites for that matter. They don't seem to have a common theme, other than the fact that they appeared in some of our host pair information, which we know that they're probably compromised. So this to me is saying that maybe the attacker has used this clicky ID as a means to track their users. So if I go over to this, the RussianEmbassy.org website, again, similar pattern, live web information in the past 6 months, several years of history through the time bar, probably legitimate information. Knowing that this particular website was referencing that clicky ID, I want to look at the trackers here too. Is there anything else that we missed? And in fact, we got some Twitter IDs, we got some Facebook information. To me, what's interesting is the Google account and account information, the Google tracking IDs here. And so, again, using some of my guilty knowledge, we have a case where there's a Google account number up top and a tracking ID that was procured around roughly the same periods of time, but there's two different values here. So if I were to go and tease these out a bit more, if I went and explored the top ones, I'm going to end up with a bunch of other, the Russian infrastructure-based website, the legitimate stuff. However, if I explore some of these bottom ones, this tracker, I end up with, again, a bunch of overlap. So again, a mixture here between legitimate web pages, some security-based websites.
Jordan Embassy now.
Yeah, we have the Jordan Embassy. We have some FrenchAmerican.org, visa obtainers, AfghanEmbassy.tj. So what's interesting here is like we have some overlap between this Google Analytics ID that may be actor controlled. It's not entirely clear. It certainly seems to point towards, at the very least, that if they're not actor controlled, that maybe there's a single hosting provider providing this Google Analytics service and centralizing it for all the properties. But that would be kind of strange. So if we go back over to our rssnbcpost.com, we now know that we got a bunch of infrastructure that appears to be compromised, that there's a JavaScript reference in place, that there seemingly appears to be some tracker information that's overlapping between them, and that we have some themes here, some government entities, some embassy, some nonprofits, some agricultural-based websites, interesting kind of people to target. One of the other tabs that we didn't necessarily explore was the cookies tab.
And this is the new data set that we have.
Yeah, this is relatively new in terms of our crawling data sets. And in fact, one of the reasons why we added the cookie data set was because of this original example. And one of the things that we observed in our crawler data set was there was a PNP sesh ID cookie being deployed.
I've heard of like a PHP sesh ID.
Yeah. So it's funny, like if you actually go and explore the rest of this infrastructure, the application or framework that they're using in some cases is deploying a PHP sesh ID cookie, which is legitimate. But to me, I know that this website's bad, and I know that that PNP sesh ID seems weird. And so if I pivot on that cookie name, I now end up with 28 websites, a lot of them being legitimate, and then a couple other ones that are sticking out as interesting to me. So we can see here right up top that in our immediate results, we don't see our rssnbcpost.com. That's on the next page. But what strikes me as interesting is I have a bunch of other domains that are deploying the same unique cookie to websites that have also appear to have been compromised and are referencing our rssnbcpost.com.
And the time period that they're up is only a few days. Some of them, like the first one, the static travelclose.org, is only up for 3 days.
Yeah, which is interesting. So maybe we didn't observe it that often. But to me, what's interesting here is we got a 2015 time frame, 2015, and now I'm seeing 2017. So I mean, maybe this has been going on for quite some time. Now I can tell you that the presence of this cookie, that cookie is driven by the actors, the malicious actors. And so if another website is deploying the same cookie and using that unique name and leveraging these same websites, then it's fair to say that anyone who else is deploying this cookie is also malicious.
Okay, or compromised.
Yeah, so well, these are compromised web pages, but the domain of delivery is the one that sticks out to me as malicious. So static.travelclose.org, www.mentalhealthcheck.net, drivers.epson Corp, US Travel Brokers, and then of course our rssnbcpost.com. And so to me, what's really interesting here is that in looking at the full picture and explaining this, we kind of were able to weave together a story here using the data. Now, the actual story that took place is that the Russians compromised a number of embassy websites, and they were disguising their JavaScript source as initially Google Analytics. And so that was the first connection point that we had. Over time, they swapped out their command and controls, and they actually replaced the Google Analytics snippet with a clicky ID snippet.
Okay.
And that's where that clicky ID connection came from. And then, during the course of all this investigating, there was a number of security companies that began blogging about this infrastructure and posting how these websites were compromised. In doing so, they exposed a lot of the malicious infrastructure, and our crawlers naturally found that references to that information on these security websites. That's why we saw that in some of the overlap. But what they didn't account for was that cookie. That cookie of PNP sesh ID was never really mentioned in public. And as a result, we were able to continue tracking these malicious operators up until their final use of the infrastructure.
So with that single data set and search, pivot search, all that infrastructure is exposed.
Yeah, and it's important to note here that this is a great example that just comes together perfectly. But this was one that was a year and a half of following it and seeing it develop over a period of time. And that cookie was not something that was readily available to us right away. But fortunately, as that infrastructure got burned, it was yet another signal that we could leverage at our disposal to make a connection to all the malicious infrastructure. So a very cool example of using our crawling data sets and how the overlap was showed us a lot of different ways of compromised websites and ongoing operations.
To bring the whole picture into perspective from all of those traditional data sets, but then leveraging the crawling infrastructure that we have to create those new advanced data sets, derived data sets, we're able to link these sites together in a way that
we wouldn't have been able to.
Yeah.
So that was a great example.
The next thing we're going to discuss is digital footprints.
Yeah.
And with digital footprints, it is your view of the world on the internet, how you look at, like on the outside, and it's your piece of the internet.
Yeah. So when you log into Community Edition, if you sign up with a corporate email address, what we'll actually do is take that email address, the domain associated with it, and we'll build out a footprint for your organization. So in this particular case, we have riskiq.com and riskiq.net that are available to us. When you go and pivot into one of these digital footprint snapshots, you're going to see an obfuscated version of the digital footprint.
And I've gone into riskiq.net. And what's nice about this is it's an interactive map. I can actually hover over and get more information about any of these hosts. And if I select it, it will then bring up more information on the right-hand side. But on the left-hand side here, this is the piece that I enjoy the most. It's the insights.
Yeah.
So if there's a framework that is susceptible to attack or vulnerable, and there's CVEs associated with, for example, I can easily come over and see CVEs that are critical, for example, and I can see a visual map of where they are. And if I select it, I can get more information about that host. But the nice thing about this is I can get to the data table and see this in a listed format.
Yeah.
And from here, I can go into the details on any of these and find out exactly why these are considered to be critical CVEs.
Yeah.
So it's just a very easy way for me to look at my own infrastructure and see what an attacker would look at to perform an attack against me, and where I might need to spend time and effort to patch or put some mitigating controls in place.
Yeah. So what I find particularly interesting or exciting about the digital footprint snapshots is that all of these data sets that we've covered and exposed inside of the community edition of the platform, all these techniques that we're employing to find attacker infrastructure, they can be turned back on a company to build out this digital footprint in an automated way. So all of the individual pivots that we make to perform an investigation, we've actually automated that at scale, and we're able to derive the footprints directly from that.
So as an organization spins up infrastructure, takes it down, let's say in Amazon, we would be able to see that as well and show what is occurring and how things are changing. So it's like an accurate inventory of what's appearing on the internet.
Yeah, that's absolutely correct. And with the digital footprint snapshots, what we're looking at here is just a subset. We're only looking at riskiq.net and all of its immediate connections. On our enterprise product, we actually go and build a complete inventory on a number of different assets, what we call keystones. And we basically build out that inventory and then continuously crawl it using our virtual web users, and then essentially identify anything that needs addressing, any potential risk to the organization.
One funny story about this is when we first launched this product, we're looking at our own infrastructure, and there was some blacklisted, one item blacklisted, serving malware, phish, scam, spam, and I kind of panicked, so I called Brandon and I go, Brandon, we have a potentially a serious problem. We have a machine that is blacklisted, serving malware and scams and everything. And Brandon laughed at me, and he asked what was the name of the machine, and I told him, and he laughed because this infrastructure is basically where we play all the ads.
Yep.
That before they go live, a lot of the ad companies will give us information about the ads. Will give it to us. We play them, make sure they're clean, and then they play them in their networks.
Yeah. So for us, we actually got triggered as serving malware, but that's malware under controlled conditions. So when Benjamin was looking at our digital footprint snapshot, he did the right thing and freaking out and understanding, hey, we might be compromised, when in reality, this was just something that we purposely did. It was part of another product that we have where we lend out our virtual users to customers who want to do ad scanning or just crawling the internet at their own discretion in areas that we may not necessarily focus in. So from Benjamin and myself, thank you very much for attending the Threat Hunting Workshop video course that we created. We hope that you got a lot out of it. If you're interested in knowing more about RiskIQ's services, or you have questions about our particular products, you can reach us at sales@riskiq.net or on our phone number
at 1-888-415-4447, or join our community at community.riskiq.com.
And it's a free service, so regardless of whether or not you've paid us or you're an enterprise user, you can register for the community edition for free and leverage everything that you saw today in terms of exercises and the methodologies that we explained. And we really encourage you to do so. Invite your friends, tell your coworkers about it, and hopefully that'll accelerate your investigations.
Thank you.
Thank you.